Hello, I would like to show you how you can utilize Edit's Flyline features to help with your device placement and floor planning in layout. Flylines is like virtual wires. It gives you visual guidance of where components need to be connected. In the SDL Browser's instance view, you can turn on Flylines for specific instances by using the Show Connected Flylines command in the context menu. This command will show Flylines for all the nets connected to the instance terminals. You can also run this command on the instance terminals or port. In that case, it will only show the Flylines associated with the specific terminals. Another place you can turn on Flylines is in the net view. You can individually toggle on and off Flylines or turn on or off Flylines for the selected net in the context menu. Let me show you how you could use the Show Connected Flylines feature to help with device placement decision. In the first example, I have some NMOS and PMOS transistors in the circuit. I will first want to focus on working on the PMOS devices first. So I choose all the P devices and then say Show Connected Flylines. So this will show all the Flylines associated with the P devices. From here, I can then choose the best orientations and placements for the transistor so that I can make the most direct and efficient connections. So in this example, I will want to place the P transistor so that the source string sharings can be optimized. And then for the connections from the P to the end, I will want to avoid any crossover. So let me do that. So next, let me look at the connections for the end devices. So from here, I can see that these two source strings can also be shared. Let me do that first. And then these two source strings will be connected, and then these two will be connected. So I wanted to place this probably below this PMOS device, and then place this NMOS also close and below this PMOS device. So let me do that. And then this, I want to align with this line, and then this, if I rotate, I want to align this with this line, and then these two should be aligned as well. So I'm done with the device placement. The rest is then just to connect the rest of the terminals based on the Flyline. So here, by using the Show Connected Flylines commands on groups of devices, it allows me to optimize connections within the groups as well as optimize the connections from groups to groups. Let's look at the second example. In the second example, I'm going to do the layout for the diff pair here. I'm going to do a common centroid layout. In the schematic, I have a M factor of 4 here. So when I instantiate the devices into layout, it will have a total of 8 devices. Let me generate this into layout. If I expand and then do the Show Connected Flylines on the drain terminal for both the left device as well as the right device, you can clearly see that these 4 are coming from the first device and these 4 are coming from the second device. Here I will place this into 2 rows. And then I wanted to do a AABB, BBAA pattern. So with that, I will want to swap these 2 devices and then also swap these 2 device. And from the final, you see that these 2 terminals have the same net, so you can butt them together. So for that, I will put it together, and so as these two terminals, I will rotate and then but so as these two terminals. I also rotate these two and then move it to overlap. Now let me create a flyline and then look at the source terminal, which is the common terminals here. You can see that these terminals are all from the common terminals, and that means I can also abut these two devices at the top and then also abut these two devices at the bottom. And then let me do a show flyline for the transistors. So you can see from the flyline that the transistors are in a symmetrical manner, and then the remaining step is to connect the terminals based on the flyline. So here, by using the Show Connected Flylines on specific instance terminals, it helps me to easily see the connections and optimize the device orientations and routing for symmetry.